Good morning, everyone. This is Joe Falco, the Product Director for Hardware Solutions. And what I'm going to do between Christopher and myself is I'm going to show you some slides, and then I'm going to switch over to Chris, and Chris is going to give you a demo, as Kelly said, of the model, working with CATIA 5. What I'd like to do first is give you an overview of both our fabrication model and the Aero Sheet Metal model, which will be used and can be utilized in CATIA 5 to develop any estimates that you might have. We do cover conventional machines and all kinds of cutting and forming operations. In the fabrication model, we cover the cutting from gas flame, laser, notching, etc., forming processes, as well as bending, plate roll bending, etc., so that you will have a full operations. Any of these operations are usable within the tool. You start out with a blank shape, and that will be picked up from CATIA automatically. Put in the length and the width, etc., the thickness of the material, all of that can be picked up from the CATIA, and that will be read into our model. The model will then use machines to do after forming operations and finish operations based on templates that we've built that are keyed off by a forming operation or a type of part. So in the conventional machines, CNC turret press, bolster, brake, and rubber die presses are available, as well as joggle, hot and cold. CNC laser, plasma arc, and gas flame cutting are all available to the user. Water jet is another option for cutting. If you have high production quantities, use dedicated tools and dies or progressive die forming. Spin forming, drop hammer, both traditional and hydroform type forming with rubber. Stretch forming, tube bending, plate roll bending, all are available in the basic model for fabrication, along with routing and straighten and check. Now, the Aero Sheet Metal portion is dedicated to aerospace type parts, and it is sectioned off the same way with preform, form, after form, and finish. And it typically will use parts of 250 thickness and down, so that anything over that typically is a machine part, right? The thing to remember about the sheet metal model, the Aero Sheet Metal model, is that it was based on over 500,000 parts. What we did an analysis based on the type of material and the forming processes, and segregated all of that data of those over 500,000 parts into sectioned by forming, after form, finish operations, so that they are the driving force to give you an estimate. So all the user need do is select the forming process, or in this case, in CATIA, type of part. You can make up templates for types of parts that take a certain forming and after forming operations, and get valid estimates by reading the data from CATIA, the material type, thickness, and the area, of course, the length and width, and the model will automatically produce an estimate based on the quantities entered by the user. And that, like I say, the length, the width, and the area will be popped in from CATIA rather than a manual entry, as well as the part thickness. It'll select the material type, and a cost will be initiated to that to give you the material cost, which many times is the largest driver in a sheet metal part, depending on the type of material. And then, as far as preforming operations, the material will dictate what operations are available. As you can see, the X's being available, like an aluminum flat, your blank and pierce form, cut to size with a shear, drill route, or drill route NC. All of those are available in aluminum and so on. So basically the model will filter through that and pick up the right operations based on the material that you put in. As far as the forming operations are concerned, we cover typically all the traditional aerospace type forming operations, from brake form, drop hammer, hydroform, hot and cold Jocko, all kinds of presses, rolling, spin forming, stretch forming, all of the kinds of things that you typically do in the sheet metal arena for sheet metal parts. In the afterform, typically, if many times, depending on the forming operation, afterform operations are needed because of like in the case of stretching, we'd have to get rid of the excess material that we use to stretch in the jaws of the stretcher. And we also may have to put in holes after the forming process rather than putting them in the flat before the forming process. So even a straighten and check, or if we're using aluminum extrusion or any type of extrusion, we can use a parts maker or do those forming operations. We wouldn't have any forming operations in the extrusion other than maybe a radius or whatever, but you would have to cut it to size or miter it, etc. And in the finishing arena, what we've done, we've picked typical finishing operations in the default templates, but the user can put in the type of finish operations that they desire or they typically use in the types of parts that they have. And the sheet metal model, it really works very well with templates that would be made for part types, etc. And we cover the range of painting, allodyne, anodize, cadmium plate, chem mill, epoxy prime, passivate, etc. Remove tooling is, zinc chromate primer, and even metal bonding prep if you're going to do a metallic bonding operation. And last but not least, if you do have drape forming or you want to platen form composites, all you need to do is to pick up the material, in this case from CAD, and we can then form those parts in the type of former that's selected. We'll have those two as two work options. All right. I don't have anything else as far as that. I just wanted to give you an introduction to the two models that are the process models that will be used within CATIA. Now we'll switch over to Chris, and he'll give you a demonstration of the CATIA model.
Thank you, Joe, for that introduction. That's helpful to understand all of the sheet metal processes within SEER for manufacturing. So what I want to do now is show how we interface all of those processes to CATIA V5. Before I go into some of the details, I want to sort of just go through a use case scenario where to show the whole process, how it streamlines the fabrication estimation process. So let's indulge me for a moment. We have cost engineer is asking the design engineer, hey, can you help me out? I need a new estimate for a new bracket that we're making. And then he gives the designer some instruction to use the new SEER-Sheet Metal Cost Estimator application. And he's telling him or her to use the clips and brackets environment. We want to make 5,000 and in titanium. And then to save that as an MFG file. And let him know when it's ready so that he can pick up the estimate for this new bracket. So let's go ahead. So now I have that information. The engineer then within CATIA is working in his part. He starts up the Sheet Metal Cost Estimator, which opens SEER and loads the appropriate settings based on the part that we're modeling. So the suggestion was to use the clips and brackets environment, which has been pre-set up. That loads the defaults for that environment. We want to make titanium alloys. We want to make it out of titanium, and we want 5,000. and we click estimate. So now we're building the estimate in SEER for this clips and bracket, and the results are sent back into CATIA, so the engineer now has an idea of what the cost is. He or she can go and look at the estimate by showing SEER. So we can see the finishing operations that are preloaded based on the environment settings, the forming. In this case, we had a conventional notch, punch, and break form, the preforming, laser beam cutting, and after forming. And they wanted to save the file and let the cost engineer know, hey, the part is now ready. The estimate is ready from SEER, so you can use it in your downstream estimation process, add it into the assembly, and so on. So that's just kind of how quick, how streamlined the process becomes when using the interface within CATIA. So the sheet metal interface itself, going into a bit more detail, it works with the aerospace sheet metal design interface or workbench, or the generative sheet metal design workbench. The part design must contain what they call a web or a wall feature that determines that we're working in what's called the sheet metal type module in CATIA. When you're working in that environment, you can flatten the part and fold the part to see the start, flatten shape, and so on. So we've created interfaces to all the sheet metal operations within SEER-MFG that Joe mentioned to you. And there's much more because we include elements of tooling, drilling, and all the detailed finishing operations. The CATIA sheet metal interface uses the sheet metal features such as flanges, bends, joggles, stamps, the part thickness, the cutout perimeters and outer part perimeters, and so on, and uses them within the cost estimate. So to start an estimate, you're going to open up your CAD file. So I'll open up something different. And then you open up the Sheet Metal Cost Estimator interface. This one has a wall feature instead of the web feature. So the next thing we would do is the types and quantities of the features for that design. They set up the shape complexity, initial shape complexity value. So in this case, we're predicting a nominal plus shape complexity, but you can override that value to suit based on your own experience. Then you're going to select the manufacturing environment that matches the sheet metal fabrication circumstances. It can be part-based, operation-based, location-based, to basically to match that part. As Joe mentioned, you can set these templates up to be part-specific or other operation-specific. So in this case, I'll just select the CNC turret press. The default types, form types that are listed for the environment, these are predefined, but we can add them, any of the other form types that are available in the list. But generally, you might set these up so they're already predefined for the particular environment that you've chosen. But if you want to override that, you can do that. The material type, you change this, it changes the available form types, as well as the process options for preforming, after forming, and the detailed part finish operations. So we'll enter in quantity. And once you've decided you're ready to go, you'd click estimate. But we'll just look at some of the available options. All of these options are available to choose and turn on or off. to include or exclude from the estimate. In this case, I'll just click Go Ahead because we've built the estimate. We've chosen the environment, entered the quantity, selected the material. We now have our initial estimate. So I can go in and have a look at that. So in this case, we have the production quantity from SEER, set up amortizations based on the rules environment file, the overall part size, the material, the press operations, in this case CNC turret press, and the shape complexity are all predefined. We had some sheet metal elements to this in the detailed part finishing. We had some epoxy prime and polyurethane paint. So you can mix and match the elements of the different processes within SEER. And again, they're all based on the choices you make for the environment and process options. There's a lot more detail in the estimate that you can review. And now this estimate essentially is ready to introduce into your estimation process and refine it. We can modify the estimate and do trade studies, so we can take a look at how that might look. So I'll remove that example and I'll choose, so we'll make this part with a progressive die. So even though we're in that environment, we're using all the other settings, except for now we've just changed the form type. That changes the process options available, that sets these according to the options that are turned on in the estimate, the environment file, and then we'll click Estimate. So this will give us a trade. So in this case, it's reduced the cost a little bit from the previous estimate of turret press, and we can now go and have a look at that, how that looks. So it's slightly different setup. We now have finishing operations from the standard finishing model, and we have the forming for the progressive dies. And the estimate itself, the results and inputs of the estimate are saved as what we call parameters. So all this information is stored into the feature tree of CATIA. So we always have a record of the estimate that we just ran, and what kind of form operations, any process options that we used, and the results themselves are all stored in the part feature tree. So when you resave this file, if you've had a previous estimate, you'll have this record, and this will become the default setup for when you re-estimate a new part or estimate this part. So if the part's changed in size or shape, or you've added more features or less features, the estimate will be updated according to that new information. So what I want to show you is, the last thing I kind of want to show you is how you would set up an environment to show you how that works, to set up a new template for use within the CATIA interface. So we have these sample environments. I'll go ahead and start one, copy one, and then I'll rename that. Let's call it ribs. They're not spare ribs. Now, firstly, we open up the MFG file, which contains all the elements that we use in the sheet metal interface. In here, what you do is now you're going to set the environment settings, but they can be the same across all the different elements of forming and after forming, pre-forming, drilling, and so on, or they can be unique for each of the different types of operations. So here you would set up your labor rates, labor calibration, product classification, production experience, any labor, wraps, and financial factors. All of these elements you would set up according to the environment you're working in. Each of the operations themselves, you can set up the typical scenario, what kind of fabrication and process tooling capability you have for that environment as well. So you would set and change these accordingly and save that. So we'll save that. Then we just go into the template editor where you set up the default operations you want to show for this environment and material. So we'll leave the aluminium alloys. Then we'll look at the material analogy wanted for aluminium type material. In this case, we choose the draw rubber as our default form operation. And then we go along and choose how we want to turn on the preform, the afterform, and finishing operations for that material type. So this sets up the default configuration, all of which you can change as required. Once you've done that, you would then save the environment. We'll just save the rules file here. And we've now essentially created our new ribs environment for use within CATIA. So the next time we fire up our interface, so I choose another different part here, and then I'll restart the interface. SEER always loads with the interface. We now choose our manufacturing environment. We now have a new ribs environment, which has the default settings for that environment. So I can enter in my quantity. Away I go. I can start my estimating process based on that new environment. So it really does help streamline the whole estimation process directly from within CATIA. So I think with that, I've pretty much covered all the main elements I wanted to show you with the interface. So if there are any questions at this point, we'll open up to those questions.